In example 2, we're asked to find the lateral and surface area of this regular pyramid. We can see that it has a hexagon for the base. It's a regular hexagon, and the base edge length is 10 inches, and we're given a slant height of 16 inches. Okay, so let's start with our lateral area. Lateral area in a pyramid, 1/2 perimeter of the base times the slant height. So in this case, our perimeter is 10 times 6, because it's a hexagon, or 60 inches. And we'll multiply by the given slant height of 16. So we can work this out. Half of 16 is 8. 8 times 60. We get 480 square inches. So we'll hold on to that measure to help us get the surface area in just a moment. Remember that the surface area for a pyramid is the lateral area plus the area of the base. The area of the base is the tricky part of this problem. In this case, our base is a regular hexagon. So we need to use some of the strategies that we learned back in Chapter 9 to get the area of a regular polygon to help us here. So we have a regular hexagon for our base. Let's take a look at that triangular slice. Remember, 6 of these slices will go into the hexagon. This triangle that I've drawn right here is not the same as one of these lateral faces. Okay? This hexagon is one of the 6 slices. It's a poorly drawn hexagon, and what happened there? It's one of the 6 triangles that make up this hexagon. Okay, so we do have a base edge of 10, and we need to find what this height would be in this triangular slice. So because it is a hexagon, that helps us a little bit because we know that this triangle is going to be a 30, 60, 90 triangle. And actually, let me redraw that again. We know that that's going to split that base edge length in half, so that's 5. So we are interested in what this apothem or apothem is going to be. We know that this is a 30-degree angle. Okay. Now, this is always going to be the case when you're working with a regular hexagon. We could do the 360 degrees all the way around this center, divide it by 6 to get 60 degrees for each of these angles, the central angles, and then split that in half again to get the 30. But we work with the regular hexagon so much we start to see these trends emerge. So that's 30 degrees, this is 60 degrees. That apothem is across from the 60-degree angle, so we know that this is going to be that base edge length of 5 times the square root of 3. And that's helpful because our base area, we remember our equation for area of a regular polygon, 1/2 the perimeter of the base times the apothem. So 1/2 perimeter, we can reuse that. It's still the perimeter of that full regular hexagon times this newly found apothem of 5√3. We can multiply these together. For right now, let's leave this in radical form, and then when we get our final answer, we'll go ahead and round that. So we have half of 60 is 30. 30 times 5, we know, is 150. So this base area is going to be 150√3. So now for our final answer, our surface area, we'll take the lateral area that we found up here, 480, add on this 150 times the square root of 3, and it doesn't tell us how to round, but we'll round this to the nearest tenth. So 480 plus 150 times the square root of 3. gives us a final surface area of about 739.8 square inches.